I don't really have regular meals. I have multiple little things.
Yeah.
It's from Hungry. Okay. Now that I'm done fighting with the computer. It was epic. Let's.
We're doing 7-H and Yoke, correct?
No.
7-7.
Oh, 7-7 and 7-6 today.
7-6 was your homework.
Yeah, I noticed. I read the number.
What problems did you do?
16 to 52. 50. Yeah.
You told me 42. I said 52.
16 is 0.4771. 18 is 0.5051. 20 is negative 0.0458. 22A is about 316,227,766 times. 22B is about 19,952,623 times, about 93.7%. 24 is 24 is 2.4899. Excuse me. 26 is 8.7429. 28 is plus or minus 1.3175. 30, x is less than or equal to 1.0805. 32, p is greater than or equal to 3.5129. 34 is log of 31 over the log of 5, which is approximately equal to 2.1337. 36 is log of 9 divided by the log of 4, which is approximately equal to 1.5850. 38 is the log of 33 divided by the log of 6, which is approximately equal to 1.9514. 40, A, is 0.067 or 6.7%. 40B is 8 years because of something like the time seems what? They did not spell that word right at all. It's some funny typo. The time seems slightly unreasonable as there would be a population growth of 300 bears in 8 years. Bears. That's a lot of bears in 8 years. 42, 0.5609. 44, 4.8851. 46, 6.9615. 48, A is less than 1.0894. 50, N is less than negative 0.9950. 52, Y is less than or equal to 0.3750. 54.
We didn't do 50.
Oh my gosh, bunch of babies. Yeah, we can do 24.
Then after that, can we do 50?
All right, how do we solve it?
We can, log.
Yeah, we log both sides. Sounds great. So we end up with x times the log of 5 equals the log of 55. Am I right or am I right?
You're right. I have a question. Couldn't we do like the log base 5 of 55 equals x, because that's what we learned as one as that's what that.
Okay, so if you did what you're suggesting and turn into the log base 5 of 55 equals x. Then you would, in order to solve that, you would have to use change of base formula and turn it into x equals the log of 55 over the log of 5 anyway. So either way we end up there.
Either way works.
Either way we end up with that.
They're the same exact thing.
And then we say it's approximately equal to something.
2.489. Yeah.
How much did you type it in? Or did this happen?
Okay, so what else from this lesson?
50.
50.
50. Those are the two digits in that.
Doo-doo, 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 doo-doo.
Two-digit number.
But you can add if they do.
Same. Two-digit number. 0 before that.
7 to the 2n is greater than 52 to the 4n plus 3. What tool from our tool belt might we use?
Log both sides.
Log both sides. I love it. We could even like preview today's lesson and take that kind of log of both sides. Why not? Natural log.
Log.
So then we end up with 2n times the natural log of 7 is greater than the natural, no, stop, go back. Four n.
What's a natural?
You're going to learn about that today. All you have to know for this in this moment is it's a button on your calculator, just like log base 10 is.
I kept mistaking my 7 for like, greater than as a 7, so it became 77 over time, and I had to redo the problem.
Distribute.
Sure, sounds fine. Let's distribute. Two n times the natural log of 7 is greater than 4n times the natural log of 52 plus 3 times the natural log of 52. Now what?
You don't do log anymore, it's just throwing it in.
Subtract.
Have you been listening in the class? Because I've been saying words about that, but it's okay. You'll learn what it means later.
Oh, that's
Today.
what it's about. I just wasn't looking.
Subtract 4.
Oh, I see.
Subtract 4 and the natural log of 52 from one side.
I think that's a great idea. Subtract 4n, is the natural log of 52, minus 4n times the natural log of 52. 2n times the natural log of 7 minus 4n times the natural log of 52 is greater than 3 times the natural log of 50, no, yes, 2. Now what?
Factor out the n.
Factor out the n. I'm even going to factor out a 2n because why not?
That works. Yeah.
So we're left with the natural log of 7 minus 2 times the natural log of 52 is greater than 3 times the natural log of 52. Now what?
Divide the big messy part from both sides.
Divide the big messy part from both sides.
Since there's a negative in there, would that flip the sign? Flip the inequality.
Let's find out. We should punch this in our calculator.
Do we have to use the natural log?
I don't really care as long as you use the same thing. You have to use the same thing this entire problem. You can't switch it up.
approximately negative 5.
Okay, so all we really care about is approximately negative. So do we flip the side?
Yes?
Yes.
Oh, okay.
N is less than 3 times the natural log of 52 over 2 times natural log of 7 minus 2 times the natural log of 52. And then you just start shoving stuff in your calculator and pushing enter.
Negative 1.9900.
This says negative 0.9950.
We have to divide n by 2 because it's 2n.
But he added 2 in, right?
I did that already, but yeah, but sure. Negative 0.9950.
Yeah.
This is algebra 2, which means if the instruction says round to the nearest 10,000th and you wrote this as your answer, I'd count off a point.
No way.
So, you know, do the rounding that it belongs in. If the answer, just throwing this out there, if the answer was this, and it said round your answer to the nearest 10,000ths, you would need to add some zeros in there.
Yay.
Because I'm that petty.
Petty, classic petty Sean.
I don't know that that really counts as petty, but it was a funny joke.
Question 22.
Nah, it's dumb.
What? 26. No, that's
Do you actually need 22? Do you have work on your page from 22?
Yeah, and I got it wrong.
Okay.
Like very, very wrong.
Okay. That's fine then.
Problem. I got 8 right.
You got A right, but B broke. Loretta has a new, for those of you who didn't do it because words, you better be grateful to Malcolm that he actually did it. Because I'm not answering questions that y'all haven't attempted.
So when we ask questions, do we have to show you that we did it?
Sometimes, if I'm feeling a little bit like, I think they just didn't do it, then I might be like, did you do it? And you'll be like, no. And then I'll be like, well, good luck. Depends on how salty I'm feeling on the day. And how much I think you're just like being lazy. So, you know, it's all subjective. Loretta has a new muffler installed on her car. The noise level of the engine dropped from 85 decibels to 75 decibels. That's the number. How many times the minimum intensity of sound, decibel, by the human ear was the car with the old muffler if M is defined to be 1?
It does give a
Thing at the beginning of the deal. Yeah, I was figuring that was probably true.
L.
Look at that. Sample 2 gives us a formula. Isn't that great?
I like word problems better in science class.
They're the same kind of problem.
But they're different in my head.
Okay. Log of 1 over M. L is the loudness, probably. Yeah.
Yeah.
Loudness in decibels, and M is the minimum intensity. And it tells us that M is defined to be 1. How many times the minimum intensity? Oh, so we got to do some other maths. What do we need to do?
So we can exchange the first L for 85 and the second L for 75.
We really only, on A, we only care about the first one, right?
Oh, that's true, right?
was the old muffler. So all we care about is the 85.
So 85 is the only thing that matters here.
Great. Now what? What?
I don't know. Solve for
That's true. Give me a step.
No, wait, M is 1. It said M is 1.
Not on this. One, that's a different, so we got to figure out this.
That was A. That was an A. If M is defined to be 1.
Right.
Times the minimum
Right.
sound detectable in the human ear was the car with the old muffler. If M is defined to be 1.
Okay, so that can't be the same equation. Like, there's no way that that works, right? There's no way that you put both numbers into the same equation, because then the variables go away, and what are we solving for?
I? Yeah. I.
Where is I?
In the second example too, it's
Oh, that's an I, not a 1.
it's I over here.
Okay, great. Let's try again. I. Cute. It's probably actually I.
Yeah.
Cute. Great. Now what?
Now we solve for I.
Great. How?
I over 1 is just I.
True. It's good enough. Now what? The I is stuck. He's attached right there.
Divide by 10.
Divide by 10 sounds like a great first step. That sounds like a glorious idea to me. Because then the log is by itself. We might be able to do some manipulations to make it happen.
Is it 85 or 85? Oh, divided.
T.
Now what?
Could we say that it could be? It was on silent. How did that happen? Anyways. Can we do 10 to the 8.5? Yeah, it is 8.5.
Yeah. That seems totally reasonable.
Now you put that in the calculator.
Or just like. It's some funky number.
Is it? What is it?
It's 316227766.
3162776.
2227.
And it's just that, or it's times 10 to the something?
No, it's just that.
Great. Is that the answer?
No, you have to figure out how many times.
That's how loud it was
You have to figure out how many times.
for A. Yeah, that's for A. But that's how loud it was, but we're not asked how loud it was.
Figure out how many times.
What is where are we at? How many times the minimum intensity of sound that's by the human ear was a car in the old month? So what is the minimum decibels of the human ear?
I don't know. We probably might be.
Where I is intensity of sound and M is the minimum intensity of sound detectable by, oh, M is the minimum. Good, great. So it's that many times. Because in order to get from 1 to that number, you have to multiply it by that number. Great, that's good. What about B? How did you get it so wrong?
I did some steps wrong.
Did you start in the right place?
I think I didn't. I think I put like.
Because you knew where the, I don't know. I don't know what happened because you knew everything,
I
but
looked at the example wrong the first time.
ah,
I put-
that makes
it was
sense.
like 10 log to the 85 of 1.
I see. I see.
So I messed
Now we do the same thing for the new method.
Yeah, and you do the same thing with 75.
Yeah.
Yeah?
up. Yay.
Ready for six.
46. Sure. So, throwing something out there, what would, just by looking at that problem and using a little bit of number sense, y minus 5 is going to be close to what number?
0. What question are we looking at?
Never mind. Y'all don't get it. It's fine. It's fine. It's fine. It's not a problem. Let's just do the problem. 46. What did you say?
2.
Yeah, that's kind of what I was going for there. Well, if you don't just see it, then let's not worry about it and just do the problem this way. Yes? Yes. Okay, great. Equals 9.2. It's a y. Okay. Well, that makes sense. Okay, now what?
Log form.
Log both sides. Great, let's do it. So, y minus 5 times the log of 3.1 equals the log of 9.2. What should we do now? I was really hoping you would say that, and no, that's definitely not what we should do right now. We could distribute, but there's a much easier path to walk down here.
Divide by 3.1.
Well, log of 3.1. Yeah, we could just divide, because it's multiplied times everything. Because that's much easier. Because, well, no. Yeah, we're going to end up with a giant mess if we do it the other way.
All we have to do is subtract it or add it back. To whatever that equals.
What am I doing?
Just do it all in the calculator.
Oh, yeah. No, I'm doing it right. Oh, I just wrote it wrong. So I would confuse myself in a second. That's why. And then we add 5. And you start shoving stuff in the calculator. You end up with 6 something.
6.961.
What? Which means that I was right, and 9 minus 5 is around 2.
You're so smart.
Yeah, because I know that 3 squared is 9. So it's got to be, that whole thing has got to be about 2-ish, yeah? True. Which means, and really there's two takeaways from that whole tirade, and then we're going to do 7 after this. I mean, yeah, 7. Having a little number sense and looking at a problem at the beginning and having a guesstimation of what the answer is going to be lets you kind of check your answer at the end. Like, does this make sense or does it not make sense? Unless it's geometry, and then you're trying to see if the picture makes sense, and it probably doesn't because it's probably drawn wrong on purpose so to throw you off, so you have to use the numbers. But this is not geometry, this is Algebra 2. Let's learn 7.
Yay.
Base E and natural logarithms.
Is the 27th, right?
Okay.
Right?
I don't know, sure. E is a constant like pi or tau, which I don't know what tau is either. No, it's not like I, it's like pi. All right? So it's a constant. It has a value, it is a number. All you have to know about it today, really,
It equals MC squared.
it does not. equal mc squared. That's a capital E, and it stands for energy.
Oh, what? No, I didn't know.
What you need to know is that it is approximately equal to 2.7, yeah, 18. I don't know why I always have to double. 2.718. And it's like pi, it's a irrational number. You don't have to care about E, where it comes from. It comes from taking logs of logs and things like that. There's a couple of really great videos on the internets that will explain that better than I am going to take the time to do today. All you have to care is it's a button on your calculator. Also, you have to care about the fact that log base E is called the natural log. Natural logarithm. And so if we have things like the natural log of E, what would that equal? If we have the log base 5 of 5, what does that equal?
1.
1. So the natural log of E would equal 1, because the base and the argument match. Wow, isn't that cute? Great. If I asked you to write e to the x equals 9 in logarithmic form, what would you write?
The natural log
Natural log of 9 equals x. Wow. Easy money, right? If I asked you to write two natural log of 5 plus 4 times the natural log of 2 plus the natural log of 5y as a single logarithm, what would you do?
I don't know, Sean. Tell us.
Yes, you do. What would you do?
Well, we would multiply them all together because they're all base.
Well, what would you do with this one?
Well, you would add the.
Turn it into
How about you just turn it into the natural log of 5 squared, right?
Yeah. Okay, that works too.
that does work.
Right?
That just works.
Properties of log. Yeah, this is a logarithm. This is log base E. He has all the same rules as any other logarithm. He just has a cool base. And if you don't think E is a cool base, it's because you haven't taken calculus yet. We like E's because the derivative of e to the x is e to the x. Lovely. E's are great. E's are exceptionally useful.
These are awesome.
So like if I add 5 to the x, it equals 5 to the x.
What? No, the derivative of 5 to the x would not be 5 to the x.
Oh, not the derivative.
It would be x times 5 plus, no. Yeah, x times 5 to the 4th, no, stop. I don't know.
Neither do
What's
I.
the 2 to the 4th then?
It would be 5 to the x minus 1 plus c. And it probably would actually be more junk than that, but I'd have to think about it too long. Anyway, what else am I going to write?
L and
L and-
Time.
Yeah.
The natural log of 2 to the 4th plus the natural log of 5y. Now what could we do?
Multiply them all together, right? Or multiply them together one by
We could do this first if you wanted.
25. Or yeah.
We could even
Long graph, Sean.
We could even do this if you wanted. We could then just bring this one down, all right? How does that sound for useful?
Yeah.
Sounds good.
And could you control
What's
400.
125 times 16?
125?
Why
Oh,
are
because
you-
of 5.
120.
Because 5 times 25 is
2,000.
125. Somebody else agree?
Yep.
16, which is 400.
How's that? For easy money, right? No big deal.
2,001.
So did we take the
Let's solve a couple of equations, shall we?
16, right? Is that what we did?
What?
The 25 times the 5 times the 16.
We did. You are correct. That is, in fact, what we did. You are accurate.
Smart.
What? I'm going to write 3 equations on the board, and then y'all should start trying to figure out how to solve them. Let's do 3e to the 4x
Yeah.
minus 12. They're examples, but I'm going to pretend like they're guided practices. Because I'm going to write them up here, and then you're going to solve them.
I know, I thought the where you wrote examples was 8x.
Oh, yeah. That makes sense.
Is it YX?
It's 4x.
4x.
Apologies.
That's why I always write my y's like this.
Oh, yeah.
Except
Yeah.
earlier.
No, I did. It wasn't quite as pretty because I didn't write it as slowly. It was written as a cursive y, though.
It just looked like chunky.
Yeah.
Right
But if I was writing a y like this, then it wouldn't have looked like a chunky whatever. You follow me? Yes? Good.
Yeah, it looks like you started doing cursive, but it just.
The point that I'm making, since you clearly have missed that part, the point I am making is that my y's will always look like cursive, even if they're ugly cursive at that particular moment.
Otherwise, they look like 4s.
And so, if you think something is a 4, it probably is. You can ask about it. That's totally fine. Minus 3 cubed is greater than 6. Ready, go. Give you a head start and then see what happens. Oh, you know, I should get some more water while I give you a head start. That's a good timer. Do 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 do. You know, I could add Easter eggs and say words. Then you'd have to watch the live to have heard the words. Maybe I'll say the secrets of the universe. See, what I need to start doing is I need to start leaving class every day, and then I should say random words outside the room, and then you will have to watch the live in order to hear the words. Maybe I'll start saying words about y'all. Maybe mean ones.
You're not that mean to us, though, Sean.
My son said I was roasting everybody yesterday.
Oh, burn. Got a cat roast or something.
I guess so. Did you make a mistake?
I did.
What mistake did you make?
I didn't know the next step. I tried something else and it did not work.
Okay, well, at least you tried something. That's good. That's better than nothing. Round your answer to the nearest. Just kidding. Yeah, 10,000th. Any questions on the first one? Do it make sense?
Yes.
Did you do those steps?
Is it a different button for like?
It's the, well, you're using log base 10.
Oh.
You got to use the natural log, which is here. Well, that's log base 10. This is log base E. See, it matches. LN, LN. Whoa! Yes, ma'am. Yeah, because 27 divided by 3 is 9. What other one? This? Yeah, it's this 9. Yeah. I just turned it from exponential form to logarithmic form. Right? Because the base is invisible because it's an E and I wrote L in, right? And then the 9 goes as the argument, the exponent goes as it's equal. Yeah.
I had the right steps, I just accidentally subtracted from the back.
Girl, you got to quit with these negative mistakes. They're ruining your life. So depressing.
Done.
Done.
I think I may have gotten it wrong, but I'm not sure.
How do you put the first problem in the calculator? If you're talking about this one, there is a button on your calculator that says LN, so, which is the natural log. The other log button is the log base 10. If that doesn't answer your question, message me again.
Is L 9 divided by 4?
Yeah.
I saw.
Make sure you close the parentheses.
I saw your live thing for teaching Algebra 1 and I thought about joining.
Did you?
Yeah.
We're learning about cool stuff these days. This is finally the part of the year where Algebra 1 is actually fun.
What are they doing in Algebra 1?
We're doing exponentials. We just got through with systems.
Because I forgot how to get rid of that. Or move it. Oh, we gotta turn it into the other.
Wow. It's the hair.
Did you know the hair is actually hiding my massive brain?
Yeah, I knew it.
Because your head actually goes into the hair, so it's not actually hair. Or it's
Brain
just your brain,
Oh,
like emerging from your skin.
right, y'all have more work
Why
to
is it
do.
so fluffy?
Focus.
It's a fluffy brain.
It doesn't hurt when I pull it out.
No.
Wait.
There's a button that you need to find.
Yeah, it's the second of the,
Yeah, it probably is.
at least on my
On most calculators, it is that. Second natural log. You also have 10 to the x on there, probably. It's probably second and log. Imagine that. Unless you have a dumb calculator and you have to hit second to get to log, which that exists. What was that? That was like a dying sheep.
dying sheep are louder.
That's probably true.
It was like a quiet after months of suffering.
How would you know?
Because I'm a sheep whisperer. So sad.
Okay.
Now,
Oh no, I missed it from the first.
If you're gonna break that one, it'd be doing that. Like doing it the other way around.
Yeah.
You gotta put the right thing on the right side and the right thing on the left side. Ah.
I did it right.
Where'd the what?
Yeah.
Oh, I don't know. Where did the cube go? Oh, I was excited about doing that step and totally forgot something existed. Can't go there yet.
What? I was wrong.
I was looking for that 3 times. Oh.
Did we just have to distribute that?
No.
What? Why wouldn't that
It's
work?
called
Oh, because it's still on the log, right? We have to put it this way.
You actually, well, you couldn't distribute it because it wouldn't be distributed. It would be this times this times this,
So yeah.
which would turn into a giant mess, which you could totally solve it that way, but you don't want to. So don't do it that way.
They call it a natural log, but how natural is it?
Pretty natural. You'd be surprised how many real world things are modeled using natural log.
Is it like straight from the forest or something?
I'm telling you, E is a really cool number. We're not gonna care enough to like teach you why it's cool today, but E is actually a really neat thing.
Did you move the L and over now? Natural law.
Yeah, that's definitely right. Yeah, I know because I'm the teacher of this class clearly.
What are we running to? What are we running to?
Same thing we've been rounding to. Wait, what did I write? Oh. There we go. 5.1945.
Yes.
Clearly, if you didn't get that, then yes. Because mine matches the key in the book, so I have fair confidence in my answer. It also apparently matches Malcolm's because he thinks he's all that in a chips bag.
It matches mine too.
Does it?
Yeah.
Well, now I might need to check it. No, I'm just kidding.
It might be negative.
Right? Yeah.
Okay, I got it.
Good job. We're so proud.
Fine.
Okay, your homework that is due on, oh, just kidding. There's more notes. I forgot. I was thinking about this part of the notes at the very beginning of class, and then I forgot about them at the end. You need a couple formulas. that use the natural log.
No.
So, y'all know about compound interest, at least a little bit, right?
A tiny bit.
Right? Compound interest is cool. Start investing like today. I'm not kidding. Like, you have $100, go put it in a good account. Let's let it sit there. Be a millionaire before you retire. Probably. Let's look that up. Let's look. How old are you?
16.
16. What's 65 minus 16?
A number.
What is 65 minus 16?
49.
49. So we're saying if you go put $100 in today, and we leave it in there for 50 years, let's say 15% compounded monthly. Sure, we don't really care about that at the moment. We're not putting any more money in because we somehow went broke and are living off of welfare for a little while. Ready, go. 75 years.
65.
No, not 65. 50 years is what I put. So, with just $100, you wouldn't be a millionaire. Sorry.
Oh no.
You would have, with just your $100, if you put it in there today, probably $170,000 from your $100. That is really good. But if you wait, and you wait 20 years to put that same $100, and so it only sits in there for 30 years, it would only turn out to be $8,000.
It's not as good.
You can't really catch up on interest.
That's right. You can't catch up interest. That's true. So doing it now. There are multiple companies that allow you to invest as a child. You just have to be like under your parents.
I think my parents have done that.
Yeah. So, do it. Yeah, like investment and companies like Fidelity or Charles Schwab or places like that.
Imagine if you put more money in then.
Right. Yeah. Let's turn your $100 into $1,000 one time. That's it. You can put more money in over time. Turn your $100 into $1,000, put it back to your 50 years, and do nothing else. And now it's 1 3/4 of $1 million. So, invest now. And then you don't have to work when you're old. You can just go fish. If you want to work, go for it.
Yeah, my ideal retirement is to go fishing.
Well, probably many of you will want to work some, but you won't have to, which is a great place to be. Because when you don't have to work and your boss is an idiot, just say goodbye. All right. So there's a couple of formulas. You've already seen some compound interest formulas. These ones are for compounded continuously. And for the idiot adults that are going to tell you, oh my gosh, you can't get 15%. Yes, you can. You definitely can. You absolutely can. Nope, not right now. Don't even have a daughter in here right now. Okay, here you go. A equals the principal times E to the, RT, right? So we've seen this kind of formula before. This one just is, if it says, we've seen ones where it says compounded monthly, compounded annually, compounded daily. Y'all seen the ones like that. We did ones like that earlier or in the unit. This is if it says it's compounded continuously. You use this one. So we know what all of these things are. What is A? Definitely not. What is A?
Amount.
Yeah. So it's the amount after T years? What's P? Principal. What's R? Interest rate. And T is what?
Time in years.
Time in years. Great.
Time in years or time and?
Time. Think about the English sentence you're saying and think about which one it would be in years. I feel like sometimes, not all the time, I would argue not even most of the time. This is probably true for everyone, so whatever, but some of the time, what comes out of your mouth matches your hair color. That was one of those times. But not always. Malcolm's hair isn't anything like that. He says things that would match your hair color sometimes too. There you go.
Yeah.
Okay, your homework.
Homework.
Page 505. Numbers. 18 through 50 evens. Okay. So, I said this the other day, but I will say it again. We have a test a week from today.
Next Thursday. Not next Tuesday, next Thursday.
Right, because we have class on Tuesday in which we will take questions on this lesson and or the study guide. And then we will have a test the week after that. There's always a study guide. There's also a practice test that are both at the end of the chapter.
I found a wire on the table.
I will even send you answers to those if you want them. You just have to ask for them. You can use photomath to help you figure stuff out. That's not a problem. Every once in a while, photomath lies, so be careful.
I was like, that doesn't make any sense.
And make sure you use photomath wisely, so it's actually useful to you.
I solve the problem and then look at it. And if
Yeah,
I'm
no,
wrong,
that's great.
and then yell at it when it asks me to pay money to look at the steps.
Yes.